This is Dr. Carroll, and this video is an introduction to recursion. Let's start off with what is recursion. So basically said, recursion is a solution that invokes itself. Now that might be a little vague. Let's dive into it more. It's a powerful problem-solving technique, and it's a special case of a divide and conquer technique where the subproblem has the exact type of the original problem, but with Let's establish some terminology. Recursion, a recursion function is a function that calls itself. So typically in computer science, whenever we talk about recursion, we're talking about recursive functions. And so that's it. You now understand recursion, a function that's going to call itself. Now, you might start to think, wait a second, if we just call itself, what's going to stop calling itself over and over and over again? Well, that was very astute of you. So this is what we call the base case. It's the circumstances or scenario, the condition when the recursion stops, so that we don't call the function indefinitely and have an infinite recursion. That'd be bad. So okay, so what's a typical structure look like? Now, not all recursive functions are going to look like this, but this gives you a start. So we have our return type, our function name, and our parameter list, whether it be an array and an index, whether it be a string, whether it be a number, whatever it is, that we have this one or more parameter list to call. Now, the first thing, and very typically we have a if-else structure. If the base case condition, then we want to handle that, and we'll do some final calculations. Okay, this is it. This is the condition of which we are going to stop the recursion. So let's do our final conditions and set a return value. But otherwise, might do some calculations. For example, if we're iterating over an array, we'll do some calculations or test for that index that we're on. Or if we're doing something with a string, we might do something for the first character in the string or some condition. Then, and here's the another critical part, is we're going to call the function itself again, but not with the same parameter list, because that would result in infinite recursion, but we need to change it. Now, how we change it could be a string, we shorten the string, maybe take off the first character or take off a substring of it. If it's an array, typically what we do is we again pass the reference to the array, but we change the index which we're looking at. So we could have started at 0. Now we'll say, hey, let's try this. Let's call this function again, but with index 1. And then it'll end up calling it with the array and index 2, and so on. And then we might take that return value and combine it with what we did for the current iteration of function name here, and then we'll return some value here. So that's the general layout of it. Now, when you're saying, I think this solution might have a good a recursion would be a good solution for this problem, there's 4 questions to guide you on that. The first one is, can I define the problem in terms of a smaller version of the same problem? Okay. The next question is, how does each recursive call diminish the size of the problem? And so usually this is, we take 1 off, we reduce it by 1. And that might seem like a very simple question, but you could imagine a very complex recursive function, and how do we reduce it? Or are we looking at a search space, and we're going to look at this part, and this part? Okay, that's how we would diminish the size of the problem. And then can we establish a base case? Okay, once the problem gets this big, then we know what the answer is. Or if we were looking for something, that means we didn't find it, or whatever the case is. So what would be the base case? And sometimes it's more than one condition of which we're looking at for the base case. And the last one is, as the problem size diminishes, will I reach the base case? Well, if we're reducing it by 1 and the base case is 0, then yes, we'll eventually get there, assuming we start with some non-negative value. And so, but we just need to make sure that we address that. So as you're considering defining, constructing, designing a recursive solution, look at these 4 questions. Now, to complete this intro video, I want to talk about iteration versus recursion. You might say, hey, iteration has served me very well. Why should I apply recursion? Well, let's talk about that for a little bit. So there are some overhead costs. An iterative solution, we're going to loop, and a recursive solution, we're going to have some function calls. So let's talk about the pros and cons here. So when we're iterating over a loop, we're going to have the increment instruction, we're going to have the test instruction, we're going to have the jump instruction, the branch either to go into the loop again or to get out. But with recursion, with function calls, we have to copy the arguments onto the stack, we have to update the stack pointer, update the next index register, copy return value if there is any, update the stack pointer, and then update the next instruction pointer. Now that's a lot. What I wanted you to get the sense of was, is there more for iterative? Are there more executions to execute for the iterative for a looping or for recursion? There's more for recursion. There's more going on there. And much of that is more of an operating systems level, but you can see clearly that iterative solutions generally have less overhead. And but on the other hand, compilers are getting better and better, and compilers can often whittle down that function call overhead, or actually replace, in some cases, replace a recursive function with an iterative version. So usually a recursive solution has an iterative solution. So, but if a recursive solution exists, if you can come up with one, often it has a cleaner implementation. What do I mean by that? It's more clear, it's simpler, shorter, easier to understand, and easier to maintain. So sometimes the recursive solution is the only solution. So you might be saying, okay, which one do I use? Well, here's the guiding rule. If there's a straightforward iterative solution, use it. If there's a straightforward recursive solution, well, then use that. That's it for this video. Check out my other videos where I'll be going through several examples and walking through code to help to teach recursive solutions. Hope you enjoyed it.